Good afternoon, everybody, and welcome to today's webinar, Successfully Managing Moisture in Mass Timber Projects. In a minute, we'll be hearing from the first of our two speakers, Matt Caldwell, after whom we'll hear from Nick Clifford. But just before we start, I'm just going to tell you a few things about Timber Development UK. TD UK formed in 2021. Thanks to the merger of the Timber Trade Federation and TRADA. We are now the largest, most comprehensive supply chain body in the UK. We feature everyone from designers, architects, engineers, to sawmills and all of the supply side. We we range from sawmill to specifier and all points in between. Here you can see our three key missions, and we carry out those missions via webinars like this one, but also from a range of other outputs. There you can see one of our two flagship print magazines, that's Designing Timber. We also have a sister publication called Supplying Timber. There you can see one of our many essential pieces of guidance, that's Moisture Management During Construction, written by Matt Caldwell, who we'll be hearing from in a minute. You can also see a good example of one of our many resources from our knowledge library using structural insulated panels. If you go to our knowledge library, you'll find hundreds of other essential timber knowledge sheets like that one. And next to that, you can see a good example of one of our case studies. Our case studies library has hundreds of examples of inspiring timber buildings of all typologies, whether they're private domestic houses, big educational projects, commercial retrofits and extensions, you name it. Basically, if you want to find examples of great timber buildings, you'll find them in our case studies library. So there's a lot of resources that are free and available to everybody, but there are also an awful lot of exclusive member-only resources. So we do urge you to join us. It helps us to put on really good webinars like this one. We'd love to have you. So if you want to find out more, please visit our website, and all the information you need to know about joining will be there. Also like to take the opportunity to remind you all about this year's Wood Awards. Entries are open. So if you've been part of a great timber building, we do urge you to get your entry in. You have until the 23rd of May 2025 to do that. So now I think I will hand over to Matt Caldwell, the first of our two speakers. Enjoy the rest of the webinar. Oh, one more piece of housekeeping. If you go to the bottom of the screen, you'll find a little Q&A box. So do, over the course of the webinar, ask any questions you want to ask in that little Q&A box, please. And now over to Matt.
Thanks, Matt. Just double check that you can see my slides.
Yeah, that's absolutely fine.
Great. Okay. Good afternoon, everyone. Thanks for joining us. My name's Matt Caldwell. I'll be taking you through some of the key considerations for moisture management of timber structures during construction. First of all, just to introduce me, some of you probably already know me, but I'm a practicing structural engineer at Buro Happold, and also carry out postgraduate research at the University of Bath. So my presentation is kind of influenced by that perspective, and so I've kind of subtitled it as viewed from a designer's perspective. And then obviously Nick will follow on and give the perspective from his experiences. Okay. You should be seeing an agenda now. These are general headings of what I'm going to be discussing, but time is quite tight, so I won't be diving into much detail on each, but there's a Q&A box and a Q&A at the end. So if there's anything you want to dive into further, we can come back to it. If you haven't had time to read the full list of the agenda there, the key things here that I want you to take away from today is that construction stage moisture is an important issue, but it can be managed, but you need to think about it. It needs thought, and the thought needs to be on a project-specific basis, so tailored to the actual scheme. And then at the end, like I said, Nick will take over and present more from the site phase perspective. Before we get going, just a shout out, as Matt did a minute ago, for the TD UK guide on the subject. It covers pretty much all the same points that we're going to talk about today. And I think it's quite a good distilled document. There's lots of information in there. I think it's probably half as many pages as the first draft. We try to really cut it down to the sort of the pithy details. So it's a good one to have in your library to refer back to. So first of all, why are we here having a whole webinar talking about the risks of moisture in timber? I think the first thing to flag, it is a very real issue, and it's potentially very costly if it does go wrong. So if you search through the sort of architectural press and what have you, you'll find examples already of where issues have arisen. And the second point is probably that it's messy to unpick once something has gone wrong as well. Everyone involved in the project will get put through the mill. It won't just be the timber contractor, it'll be the consultants. And obviously the client is left with a mess to sort of clear up as well. So it's in everyone's collective best interest to make good decisions related to the construction stage and moisture. It's also a subject that's now very well known to the insurance industry. And traditionally, that's been something that's made realising timber projects slightly more difficult. But they're very well clued up now, and they'll look favourably on the project team that has given it proper thought and demonstrated it. So that's the camp we all want to be in, obviously. So jumping to the issues themselves, there's a number of ways that timber might come into contact with moisture. During the construction stage, probably the most likely in most situations is precipitation. But there are other effects to think about: condensation, vapor, and then as the building starts to get fitted out, obviously you're putting in all your wet surfaces, which is another potential source of moisture. And if the moisture does come into contact with your timber, there's kind of a continuum of potential effects. And in basic terms, the effects get progressively worse with increasing quantity of water and the duration of the wetting. And this is kind of a whole subject in itself, so I won't go into the detail. But it is quite important to understand that the implications of how long it's wet for. Again, it's covered in the TD UK guidance document to some extent, but yeah, it's definitely something to read up on and understand. And you can see at the left-hand side of the continuum here, you've got just something which is some timber which might be damp temporarily, and it might not go any further than that. But that may leave behind some staining, and that might progress into mold and ultimately potentially fungal decay. And some of these may be acceptable in certain circumstances. Fungal decay will never be acceptable, but some staining may be acceptable depending on what the building is doing and whether you see the timber in the final condition. You've also got moisture movement effects, so principally swelling of the timber perpendicular to the grain, and the timber does have a loss of strength and stiffness while it is at a higher moisture content as well. So all of that really needs considering. So just thinking about how we design for construction moisture, and I'm going to be talking here from the designer's perspective, so starting quite early in the process. And a key tool here is a construction stage moisture control plan. That's the term that we've used in the TD UK guidance document. Other people might call it something slightly different, but ultimately it's all trying to do the same thing. So what would a construction stage moisture control plan aim to do, and what does the process look like? This is a bit of a flow chart to kind of illustrate what it might look like in a typical situation, moving through stages, looping back on itself, and so we'll dive into a few aspects of it here. The first thing to note here is if it's going to be effective, it needs to start really early in the project. So I've said here it's a tool for design and execution. The detail will develop over time, so early in the project, it might be quite high level, and then as you work through the project, you'll add layers of information as the design develops. But some of those early stage design decisions are the ones that have the biggest effects. So, for example, at stage 2, RIBA stage 2, you might be looking at the roof. So the roof geometry could be a very critical part of what happens later. And this is not just construction stage moisture, but ultimately moisture in use. So does it have a fall? That might be something that is baked into the design at a very early stage. So it needs consideration at that early stage. So it's a tool for guiding the design. Doesn't mean it needs to constrain the design necessarily, but it helps to raise the important issues nice and early. Traditionally, sometimes construction stage moisture control plans have been something that has kind of just come along later, and might have been written into the spec that the contractor needs to produce one, and then nothing more is done on it until a contractor is appointed. But obviously at that stage, if it's only starting to be thought about then there might be some quite significant hazards already sort of baked in. So yeah, starting early, considering it early, and if you do bake in some high hazard situations, then it's very likely to affect mitigations that you have to take during construction and in service. So essentially what we're doing here in this first stage is a project specific risk assessment, and it's a risk assessment related to the moisture. So until we've defined our objectives, we don't really know what we're aiming at. So that's the first thing to do. So your objectives for different building types could be quite different, as I mentioned earlier. If it's a industrial building or maybe an agricultural building or a factory, or if the timbers are all going to be covered in the final scenario, then the visual requirements of your acceptability criteria will be very different to if it's in a school or an office or a dwelling, perhaps, where all of the timber is ultimately part of the finishes and kind of almost the furniture of the building. Then the controls need to be tighter. So you need to define that at the start so you know what you're aiming at. So effectively, on the continuum of effects that we talked about earlier, where are you going to draw the line? Where is it acceptable to get to? And once we know what the target outcome is and what the objectives are, you need to look at the hazards that you've got in your particular design as well. So, for example, if you've got a large flat CLT roof, that's probably could offer a large hazard, and can you adjust for that? If the CLT surface is quite uninterrupted, then you might decide that that's acceptable. But yeah, identifying those things allows you to move to the next stage. And this is an extract from a document by RDH Building Science over in North America. They've got a good diagram here that's identifying some sort of hazard areas, and there are other documents that do a similar thing. And quite often, if you just take a cross section through your building, it's not too difficult, as long as there's enough detail in there. It's not too difficult to sort of start to see where, if rain lands on here, where will it end up? Where is the exposed end grain? Where are your particular hazards? So once we've identified the hazards, we can match them up to potential mitigation measures. And so they might be design mitigations, so changing the design or adapting the design, or they might be measures that are going to need to be taken on site. In the case of a large flat CLT roof, we might consider things like giving it a pitch. Can we build it and waterproof it in sections? So if you've got a very large plan area, can you go all the way up to roof, enclose it before you move horizontally? What temporary protections could we use? Self-adhesive membranes, or just enclosing it potentially, temporary enclosure. Or if the mitigations are limited, then maybe we need to change the way that the roof is structured and materials and what have you. But if you're considering all of this early enough in the design process, you've got the most opportunity to influence those big ticket items. So you've got more chance to release the construction stage to not be so heavily constrained. And as I said earlier, all of these things really, although we're talking specifically about construction stage moisture here, most of the decisions you can make which have a positive effect during construction will have a positive effect in the in-service stage as well. So in each case, you've got your objectives, your hazards, and you evaluate your risks, considering that you've implemented certain mitigations. And then you decide whether those risks are still acceptable, the sort of residual risk. If not, then obviously you loop back. If during the project something changes, the geometry of something changes, just need to consider how that might affect this construction stage moisture plan and to update it. It can be hard to put sort of very specific kind of rigorous numerical measures to it, but even an approximate estimation or qualitative measures, a qualitative measure of the risk is still a good place to be. It's still an effective process. So this is what the format of your risk assessment might be. You identify a particular hazard, explain or explore what the basis of that hazard is, how likely is it, how severe it is, and then what mitigations can you apply to try and reduce the risk. And then at the end, is your reduced risk, is that acceptable? So it's the similar format to other forms of risk assessment, obviously. Once we've settled on the risk assessment outcomes, you need to record it all in a coordinated planning document. And then it's clear what you've assumed and how it will influence the execution stage, so that you can communicate it to other stakeholders. So the contractor would be a primary example. And a version of this needs to be really in circulation while the building is being designed, not again something that you leave till later. And then once the contractor's on board, they can then see all your assumptions and how you've assumed it might be built. And then you're almost certainly going to have to loop back when you've got their feedback. And the earlier you can have the contractor involved, obviously, the better in that perspective. So that means once you're on site and you're into the execution stage, you should have the solid plan written down that everyone's bought into. You'll have anticipated the hazards that you have in your project, identified which mitigations you need to have in place, how they'll be implemented, and you've decided how you're going to monitor the execution stage. So make sure that all those mitigations that you've implemented, make sure they're working, and then also have some backup plans ready. So if you find certain issues do crop up, what do you do at that stage? And you also want to have a predefined way that you're going to record what's happening on site. So moisture, recording moisture measurements in the timber, the weather, what you've observed. And that allows you to rigorously evidence it at any point during the execution stage, but then also later on when you've got a package to hand over and evidence what you did and what condition the timber was in through the process. And you might find that that's something you rely on later. If worse does happen and something goes pear-shaped, at least you can show what you'd been doing. So just taking a look now about at mitigations, what they might look like. Sorry, something more here. The fundamentals aren't really rocket science. In most cases, rain falling from the sky is your primary problem. So and it does tend to come in sideways sometimes in this country, obviously. But if you take that as your biggest hazard or source of the hazard, then you can't go far wrong with providing a good hat and pair of boots for your structure. So this is sort of paraphrasing sort of, what's that, 19th century quote about how to protect a cob wall. But if you can stop rain landing on it from above, and you can stop it being soaked up from below by not putting it in a puddle, then you've gone a long way from the start. And talking about construction stage, you can also extend the analogy to say, you know, if you could provide an umbrella, or if you could give it a jacket while it's sorting out its final condition, then that would be the logic. And another way to think about it is to think about the 6 Ds that I've got here. So I've taken the 5 Ds of moisture management, which is proposed by Beebe and Cam Byron, and the quotes, the references at the bottom there. I've sort of extended it and sort of adjusted it to suit our situation. But running down the list, yeah, it's really just tracking the gravity path of moisture or rain landing on your structure. So can you disrupt that? Can you build it in a particular season? Perhaps that's effective if it's a very small structure. It's unlikely to be practical for larger structures. Can you build it more quickly? That reduces the time of exposure. Or if you're building in stories, can you quickly build 3 stories and then take effects at that stage before you go up another 3, perhaps? Is using naturally durable timber or treated timber relevant? It really only buys you time. It doesn't sort of get rid of the problem. Can you deflect the water away from your part-built structure? Could you have a temporary roof or sheeted scaffolds, certainly for sort of part of the construction stage? If water does land on your structure, how can you drain it away? So how are you going to help it to run off your structure? That could be passive measures like a self-adhesive breather membrane or hydrophobic coating. Obviously, having a fall to the timber helps enormously, actually. And then sort of taking it to a piped outlet, so you're managing what happens to that water when it's run down your slope. And maybe even the simpler things like tarps and covering up the holes for windows in your structure. Or the drainage could be an active measure. You could have brushes, squeegees, wet vacs, etc., to help get rid of that. The next D that I've added in there is detection. So that probably covers everything that allows you to know that you've got water somewhere. So that could just be visual, to be honest. That could be walking the site and looking for wet patches. It could be digital leak detection or digital measurements of moisture content in the timber. And then a final mitigation that you have in principle got is to dry it out if it has got wet. That could be passive drying, so just once it's no longer being wetted, just leaving time for it to dry. Depending on how much water you've got in there, that could take a lot of time. Or actively drying it, so you have to enclose it and then pipe controlled humidity air across it. That's obviously, that can be a pretty major operation. That's not something you want to rely on from the start, and remove other mitigations on the basis. As I mentioned, backup plans. What happens if you're recording what's happening on site? And you find that the mitigations aren't working, or maybe you just had an unusual weather event or a delay with follow-on trades or something. What you don't want to do is suddenly be thinking at that point about what you can do. There's a lot of thinking that you can do beforehand. Some of it's quite simple, you know, just access to wet vacs and fans, some tarpaulins. Maybe you've already contacted some scaffolding suppliers and you've got a quote and an idea of how you would enclose that building if you needed to. It just means that when you have a problem, you're not sort of scrabbling around at that point. You've already got some plans in place, and you can just put them into action. And then if you have got, I suppose it's the next level of backup plan. If you do observe some degree of damage to the timber, you also want to have thought ahead of time and talked with other stakeholders about how you might make good. So if it's just a little bit of water staining and you catch it early, maybe it might be enough just to wash it away with some water. Maybe you need to go to the next stage and have sort of an oxalic acid solution or something like that once the timber's enclosed. Sanding away timber is definitely something you want to have agreed with other parties before you go at it. Obviously, it changes the way the timber looks. If this is going to be it takes material away. If it's going to be exposed timber, then you'll be changing the texture and potentially the colour. So yeah, you do need to need to make sure that's been run past the right people first. And in the really worst case scenario, could elements be repaired, and how? Are there particular elements where that is impossible, where you need to sort of step up your mitigations from the start? And also an important point is making sure this isn't just a kind of academic exercise, that it's grounded in the real world where you have constraints on time and money. A full temporary roof, as you see here, is obviously going to be a very effective solution, but it will have financial and logistical costs which might not be appropriate to your project. Whereas just taping the joints in your CLT roof is cheap and quick, but is it going to get you to where you need to be for your particular scheme? Likewise, active dehumidification and drying of your structure could be viable, but again, it's got cost and time implications. Maybe it's something that's only really viable once your building's closed in. So maybe if you're doing a load of plastering and creating high humidity at a late stage, maybe that might be appropriate. And if you are doing kind of retrospective drying because you've got a problem that you didn't foresee, that is going to be very costly and take a lot of time. So again, that's really your last line of defense. You don't want to be planning to use that, I'd say. So a word on when you're monitoring your structure during construction and recording what's happening to it. There's potentially quite a lot of data there, so you need to work out how you're going to manage it and track it. And long before the timber's on site, you need to have kind of all the templates set up so that you can hit the ground running when it starts. You don't want to be discovering a month in that you've got stacks of bits of paper and information recorded in all different places. You're not really going to be able to use it unless it is recorded in a kind of coherent way. So in summary, there's some quite simple principles to implement, really. And a lot of it is, the process is analogous to any other risk assessment and planning process, really. And as I said before, there's a lot of detail to this. I've only really skimmed over the surface here. But in summary, the construction stage moisture is an important issue, and it can be managed, but it does need thought, and it needs to be thought about on a project specific basis rather than having a kind of generic document which you kind of pull out for every project. You need to sort of tailor what you're doing to that specific project. Yeah, and it has been done. It can be done. This is a lovely old structure, been around for a long time. There's a few things there. So it's got a pitched roof, it's got overhanging eaves, it's up off the ground, it's ventilated, and it's been maintained and repaired over the years. So yeah, it can be done. So don't be disheartened. We can do it. There's lots of options here for us. Okay, now I'll pass over to Nick to talk more about the construction stage.
Thanks very much, Matt. Yes, as Matt just said, passing over to Nick, who's doing a sterling job answering many of your questions, I can see. So yes, there should be time at the end to catch up with those. But if you'd like to start sharing your screen, Nick.
Yes, good to go.
Looks good to me.
All right. Hello, everybody. Thanks for joining us today. So I'm Nick Clifford from TIAS, formerly the Senior Timber Technical Consultant at BM Trada for some years before that consultancy closed at the end of December. Yeah, I'm here today to talk to you about some, basically some moisture monitoring, the way to monitor moisture for CLT projects. We're going to look at various aspects of moisture monitoring. We're going to look at what your contractor is going to need to do on site. We've got all the paperwork in place. Of course, we've got all the forms and all the planning. How are we actually going to deliver this on site. You need a contractor that's going to need that knows a little bit about it, and we will be looking at the sorts of skills that you might be looking at if you're a contractor, that you might want for your teams, or if you're selecting a contractor. What are you looking for in terms of demonstrating competency to be able to deliver moisture management during the construction phase? We're going to look at how to monitor moisture and where to monitor moisture during your site. I'm going to look at documenting and presenting moisture data very easily to get. It's quite easy to get misleading moisture data if you take your readings in the wrong way and in the wrong place. And so we want to make sure that we avoid that. And then we need to focus on the operational risk zone monitoring. There's a lot of talk about construction phase monitoring, but a lot of damage that's happening in CLT buildings is happening in service during the operational phase. And we need to think about how we're going to mitigate those risks too. So we can't just concentrate on the construction phase. And so we're going to have a look at that today. So first of all, it's widely known that you need to have site moisture management and monitoring. And you're going to need a contractor who's going to be able to deliver that. And so we want, when we're looking for a contractor, or if we are a contractor, we might want a site team that has had some training and understands the risks that are particular to CLT. They're going to need to understand the risk zones. And so this picture on the left here, this is highlighting our risk zones in our this is a flat roof panel, which wouldn't necessarily be recommended anymore, but these are the risk zones. It's basically along the highest risk zones are along the panel junctions. And we're going to have a little look at why those risk zones, why that is a risk zone, and how we check that those areas have stayed nice and dry during construction. In the middle here, we have a sign that we haven't had great site moisture management. That is a discoloration from wetting percolating through the joints. And that is something that your contractors should be checking regularly, looking for signs of that sort of thing. To get that amount of discoloration, that's been going on for a very long time. Oops, sorry, let me just go back to the previous slide. That's been going on for a very long time. It shouldn't be getting anywhere near that amount of staining with good quality site moisture management. And that means things like regular checks, planning to have the right personnel in place, the right equipment to remove moisture from the building in rainfall, and also to be ready to react and have some repairs in place. There's lots of things that the CLT supply chain do to help you with your project. They will send, if you specify them, they can send you panels that have already got waterproofing membranes on them. They will help you a great deal of managing moisture. Helps a contractor, really does help them during the construction phase. But they're not bulletproof insofar as it's a construction site. There's a very good chance they're going to get damaged in use. And so you as a site contractor will need to be managing that, going around, checking for signs of water ingress, reacting quickly, knowing what to do if you do get signs of water ingress like this. It shouldn't be getting anywhere near as far as that. Your contractor should also need to know how to check whether they're managing to keep moisture out of the building. And they need to do that using the right equipment. So are you a contractor, or has your contractor, can they show you that they know how to monitor the moisture and what equipment to use? So what of interest here is, so we have 3 different types of moisture measurement probes. And these are measuring at different depths into the timber. And that's really important when it comes to measuring CLT, the moisture in CLT. You need to be checking exactly the right place in the panel thickness. Otherwise, there's a very good chance that you're going to get readings that tell you that the panel is dry when it might be wet. And so we're going to look at that in a bit more detail. And I'm going to show you a relatively new technique for measuring moisture in CLT panels. It allows you to precisely target those risk zones. So in order to target the risk zones, we need to understand where they are and why they are. And that is, so the risk zone, it's quite widely known, is at the edge of a CLT panel. Much greater risk at the edge than it is in the middle, away from the edge, I should say. And that is because of the difference in the way that timber behaves on exposure to moisture. It takes moisture up through the end grain, and it's very difficult to get moisture to go into something like spruce, which is commonly used for CLT in Europe. It's very hard to get that to go in through the side grain. It can sit in standing water for quite a long time in the side grain. You get very little moisture uptake, very little penetration of the moisture. But there are zones in every panel that where moisture uptake can happen very quickly. And so we need to be looking at those areas, targeting those areas for our moisture monitoring in order to be sure that we've got a nice dry building before we close in. And my recommendation, I've seen recommendations that are say within 300 millimeters of take your readings within 300 millimeters of panel edge. It's too far as far as I'm concerned. And my experience is that you need to be within 100 to 150 millimeters of panel edges. Otherwise, you can end up with a dry reading, but the edge of the panel is wet. And very often the edge of that panel is going to be the bearing zone, the bearing length. And so that is why there's good reason to take your readings within 100 to 150 mil, the panel edge or end, or cut out or hole, or wherever it is that you've got exposed end grain. And we need to take our moisture test locations in these areas because they target the higher risk zones. And now I'm going to show you how to precisely target the risk zones for moisture monitoring. So let's have a closer look at the panel layout. A lot of people already know that this is cross-banded timber. It's basically planks laid cross-banded to one another. And so using our referencing, I use the upper layer I call L1, layer 1 or lamella 1. That is cross-banded in comparison to layer 2, and layer 3 will be back in the same orientation as layer 1. Very often, the panels will generally have an odd number of layers to help balance them, keep them flat. And so if we look on here, we can see that if I'm taking a moisture reading in this top layer, if I take it over here, it's side grain. There's very little chance of moisture being taken up through the side grain. So in this top layer here, my reading, I'll be taking a reading from the end, right? So targeting the end grain. Whereas on the next layer down, I'll be targeting this area here because that's where there's end grain. Whereas there's very little risk of moisture uptake through the side grain on the layer 2. And again, end grain of layer 3 is where moisture uptake will occur. Side grain, very little risk of moisture uptake. And so that's how we're that's where we need to take our moisture readings. And so this is where the new precision comes in. So what we're looking at is, so I tend to use the long insulated deep probes for my moisture testing. And I tend to do it from below the panels because very often, as I say, there'll be membranes and protective, wet guard and Rotherblast do a membrane as well as Sega. And these will be protecting the upper surface of the panels. You don't really want to be poking holes in those to take your moisture readings. Okay, so I tend to do it from beneath, but I'm interested in targeting the correct lamella. So I do 6 mil holes, just easy to insert the probes, and I tend to put them about 15 millimeters apart. Doesn't make that much difference whether it's 10 or 20 millimeters, but about 15 millimeters apart will do. And if I'm targeting L1, the top lamella, that is the depth that I'm going to be drilling my holes, targeting the center of that lamella where the end grain is. Now, if I'm going to be measuring on the second lamella, I will be making my holes much shorter. If I drilled them up to this height here, I'm going to get a dry reading with my insulated probes. But this is where the moisture uptake would be. And this is where the moisture uptake would be. And so what we do is we target our moisture monitoring deep probe holes to the correct lamella. Now, let's extrapolate that now to a full-size panel and have a closer look for what that means in terms of us taking moisture measurements on site. So on the left here, we have longitudinal face planks. Now, this is a really common orientation for most horizontal panels, floor panels, roof panels, that sort of thing. Excuse me, that sort of thing. I'll stop doing that. We have longitudinal face panels. So on this panel here, if I am taking a moisture reading to see if there's been any moisture uptake, the L1 and L3 are the areas on the end of the panel where there's likely to be moisture uptake, if there is any. If those areas are dry, the end of the panel will be dry. But if I was to take readings from that top lamella halfway along, well, now I'm reading into side grain, a lamella that's got side grain exposed, and there's a chance that I'll get a dry reading when actually there's moisture in the second lamella. So readings along the longitudinal edge of this type panel should be targeting the second lamella and potentially the fourth lamella. Now, it does change a little bit based on your panel makeup and orientation. Sometimes there's a double layer where the lamella's facing the same direction, but you can figure that out on site. There's usually somewhere where you can see a panel edge or a panel end, and you can see the thickness and the number of lamellas and their orientation. You just adjust your reading depth accordingly. So on the edge of a panel, I'll be taking a reading from the second lamella here, and on the end of the panel, I'll be taking the reading from the top lamella, typically. and sometimes a third one as well. There's usually 5 or 7 lamella, but this for the sake of illustration. But on your very often your wall panels, you get transverse face planks, right? And so I don't really need to be taking very deep readings on this particular, if I'm trying to figure out whether this panel was taken up any moisture, I would be looking to take readings at the bottom within 100 to 150 millimeters of the bottom edge, and I can do it in the face lamella because that is where moisture is going to be uptake, because the end grain will be facing where there might be some standing water or something like that. Or if this is a parapet wall, then we're looking at, is this protected during construction to stop moisture uptake during the end grain? So that is how you target your at-risk lamella. Now we need to be able to report that data, and there is a big difference between robust moisture data and moisture data. And the important factor is you need to have several bits of information in your moisture reporting, pertinent bits of information. Without that, the data is virtually useless. So what we need to know is the test method. We need to know how we took it, when and how, where, when and how. So whereabouts on the panel did we take it? Now you might just put a test methodology that all the tests were taken within 100 to 150 mil of that panel edges, right? We need to know the dates of the readings. Importantly, we need to know the thickness of the panel and the depth that we took the reading, because that tells us that we hit the right lamella. Okay, so we want to know about the panel thickness. Where was our reading depth? What was the date of the readings? And obviously, being able to record the readings over time allows us to get a sense of whether things are getting wetter, is it drying out, or is it staying the same? And you present those as tables of results. And sometimes you might want to include photographs of test locations. So that is the sort of stuff that I expect to see in a robust moisture monitoring report. Now, there's all this guidance about you've got to do site moisture monitoring and we need to record everything. Nobody actually says how many tests you need to do. How do you find out how many tests to do? Well, I can tell you my rationale for how I would do it. Now I have been doing it. I've probably done over 1,000 tests this year already. So you basically need, there's no formal guidance, but you need quite a good spread. And how are we doing for time? What is the time? How are we doing for time? We need quite a good spread. Matt, Milton, am I all right for time? Okay. And we need to target our risk zones with the high-risk lamella. So we're basically taking most of our readings are going to be along panel junctions. Okay. Now we're going to occasionally take a reading. This is for construction phase moisture. We'll occasionally take a reading away from the panel junctions just to check there aren't any issues there. But ordinarily, I typically take a reading. Say, it depends on where it is in the building. For example, a roof panel, far greater number of tests than I'd have on an intermediate floor. The ground floor walls, I'd have much greater number of readings than I would on a floor on the second or third floor, because of the risk of standing water on the slab, which we don't want. And so the sorts of, stop doing that. The sorts of things that I do, very often I might take a reading, I'll do one on either side of the panel junction. Sometimes I might do it 1/3 and 2/3 of the way along the junction. I might not do every single panel, I might skip a junction, take one, skip a junction, take some readings, skip a junction, take some readings, that sort of thing. End up on the roof. I'll be taking some readings at the bottom of the parapet upstands. And in this case, the P1, P2, 3, these were all dry at the top of the pitch. All the parapet upstand readings at the bottom of the pitch were wet. And so there's no formal guidance on how many tests you should be doing, but my rationale is look for patterns, greater number of tests on the roof panels, and just reduce it as you go down the building until you get to the bottom edge of the ground floor panels where they're set on the slab. So the reason that we need to do this moisture monitoring on site and that we train people to do this sort of moisture monitoring on site is because we're trying to avoid the sorts of delays and the costs that might be involved with if your site gets caught out with construction phase moisture uptake. And so this is just an example, just to give you an example of the sorts of things. It's no good just building putting a temporary enclosure over the top and whacking in a dehumidifier. Not going to work when it comes to drying out CLT. You just don't get anywhere near fast enough drying rates. And so active drying is usually required. And that involves things like with warm, dry air, blown through ducts and through small enclosures that target the risk zones. This site here got caught out with moisture uptake in panel junctions and at the base of the parapets. So they built these little enclosures, just a couple of battens and a bit of plywood over the top, and then they ducted the warm, dry air in there, and that was very successful in drying out the panel junctions. It still takes some weeks, but that is the sort of thing that you might have to do if you do get caught out by construction phase moisture uptake. Just wanted to go through, just talk a little bit more about moisture monitoring reports for the construction phase. Now, some useful timings for doing moisture monitoring reports. And I think there are 4 stages that you should probably be thinking about having some sort of moisture record. So you want some sort of record to say that the things arrived to site and were stored on site. You know, they're manufactured nice and dry. Were they still dry when they got to you? And are they being stored appropriately on site so they would dry before they would start to be installed? From handover, so your supplier or erector, erection crew will be building the building for you and then handing it over to the main contractor. At that point of handover, you as a main contractor should be expecting to receive a fairly robust moisture monitoring report that includes the sort of data that we talked about earlier, so that you can be sure that the building is dry on handover to you. Then we want some construction phase moisture monitoring for our moisture management plan and recording throughout the construction phase. So you need to make sure that you've got the right team involved. It's not sort of, you can't just give it one person responsibility for it, particularly on a big site. You need a team of people keeping their eye on moisture, regularly going around doing checks and recording the data throughout any drying works, if any are required. Hopefully not. And then the really key data point for moisture monitoring is on the closing up works. It's kind of like a final data set for the construction phase. And if you can show that that building is dry on closing up, that's important for you as a contractor because you've shown that you've delivered a dry building. And it's an important, and that's going to be important for your insurer. And also additionally for the operational phase, it's kind of a starting point. It's a fresh slate for the operation phase of the building. So the building owner, the designer, developer, the user, the building user insurer, they want to see that key data. That did we start off with a nice dry building? And so if you've got those 4 different phases of reporting in place, you're doing a really good job of moisture monitoring for the site. But let's not think that that's job done, okay? The operational phase is equally important, if not more important, than moisture monitoring during construction. A lot of the severe decay events that are occurring that have occurred in the UK CLT buildings is down to issues in the operational phase. There are some, of course, that are attributable to construction moisture. There's an awful lot that are down to operation phases. So let's have a quick look at how we're going to do that. And before I start on this, just like to say thank you to Tektor for allowing me to use some of their images. And I'll just talk a little bit more about the types of sensors that Tektor and others do that are going to be really important in terms of de-risking your building. Your building's insurer is going to want to see this sort of thing included in your proposal for your design. And we're talking about operational phase moisture de-risking. It's hugely important. And design phase, the design phase decisions, de-risking the building during the design phase is way the biggest factor in terms of mitigating moisture risk in CLT. If you are going to include higher risk details like flat roofs or green roofs or blue roofs and all this sort of stuff, then you really do need to mitigate those risks and show your insurer what you're doing, because you're designing a building with a much higher risk than needs be. And so one of the ways of mitigating those risks would be using sensors that target the high risk zones. Now, design phase, for example, you can reduce the risk zone size by having a pitched roof. And now your risk zone is at the bottom of the pitch and not across the entire roof sector. You can use these sort of sensors, which very often they can sit on top of the vapor control layer, or they could be just affixed directly to the timber. It might be that, for example, you have a sensor under every rainwater outlet. That would be my advice, to avoid leaks from rainwater outlets running down the facade, CLT facade. They're an early warning system that they're very beneficial for the construction phase, but they are crucial for de-risking the building in the operational phase. Just in the normal run of things in the building, you get plumbing leaks or a gutter leak or something like that, you need an early warning system, and these digital sensors are really good at doing that. The Tektor system is very good. That's the sort of thing that if considered early on, people are aware of sensors, but they seem to get value engineered out or just not included. They don't give enough, people don't give enough consideration to operational phase de-risking. And insurers are picking up on that, and they are going to, this is a good way of demonstrating that you de-risk the building moisture-wise to insurers is to include digital sensors. And you should go and speak to the specialists about what they can do, what their systems can provide to you. Another thing is to make sure that the people who are using the building are aware of the sensors and how to use them and of their importance. And so you might include sensor checks in building maintenance manuals and things like that. That's a really good way of helping to de-risk the building. Not just construction phase, operational phase is as important, if not more important. And so the sorts of things that we're talking about here is where we have sensors installed in the higher risk areas, and they're detecting moisture the whole time. They're checking for moisture the whole time. And if you get an increased moisture level, you get a ping, you get a signal, they'll alert you to that. And that early warning system is absolutely critical in terms of de-risking the building and minimizing problems, potential problems. So that's what you might do. And again, thanks to Tech Talk for letting me use that. And so the sorts of things that you might be thinking about for a successful moisture management, moisture monitoring for your project is your site team, your contractors, are they trained to be able to understand the risk and to be able to react and be able to measure and monitor moisture during the construction phase? And in terms of the design, that's really important. So pre-construction workshops, your project managers and designers and developers, they need to be able to demonstrate that they're mitigating risk for their particular design. Site moisture testing is something that's always going to be needed, and unfortunately, it might be that if you get this wrong over time, you can end up with some moisture damage or some fungal decay that needs to be evaluated. So that we can, sorry about that, so that we can check the extent of the damage and see what needs to be repaired. So those are the sorts of things that you need to do, and that's me. Over to you, Matt.
Brilliant. Thank you very much for that, Nick, and thank you to Matt. We've had loads and loads of questions. We can't possibly cover them all. What I will try to do is compile them all, and the many responses that both Matt and Nick have already typed and get those sent out. I mean, the one overwhelming message that I take from both of your presentations is that, you know, design phase considerations are the most important, and the most important, I suppose, where the opportunity it is to cut off at the pass, you know, any moisture problems you're likely to have. That in turn did make me wonder. I noticed, Matt, you'd replied to somebody asking about leaky pipes, and there was another question asking about designing with repairability of certain areas. So that made me think, no matter how scrupulous you are in a design phase, there are things that we know are very common to buildings. A pipe probably is going to leak at some point. So I suppose my question is, should you be designing with a view to some areas inevitably are going to have that access to repair them?
Yeah, I think that's part of the principle of having doing a risk assessment, because it's not just a risk assessment for your building compared to other buildings, but different regions of the same building, for example. So yeah, like you say, if you've got shower rooms and you know, bathrooms and what have you, that is a high hazard space. So in the course of it, we want our buildings to last 100 years, right? And every bathroom over the period of 100 years is going to have some water spill over the side or come out of a pipe or something. So yeah, the measures that you take in those areas might be different, and likely would be different to elsewhere in the building. Yeah, and you know, different forms of construction, prioritizing that kind of passive detection of a problem is a really good one. As you know, if you've got something leaking away under a floor finish or behind some wall finishes for months and months, years and years, that's when you really get the problem. If you have a pipe that bursts and you know about it straight away and you get someone in to sort it out, timber can deal with getting wet temporarily. It doesn't, you know, it's not Weetabix. It doesn't suddenly just disappear when it gets wet. It takes time to for those problems to start to happen. So if you know that you've got a problem with your pipe, that's the first stage. So in larger buildings, you might be making sure that you route all of your wet services or all that you can above a ceiling rather than under a floor, or minimizing the number of bends and fittings. And it's the long runs of pipes are not usually where you get a leak. It's normally a bend or a connection or something like that. So understanding where they all occur, if that's in a dedicated riser and you can have a drip tray and leak detection in there, then at least you're not asking for leak detection all over a building. You're just picking out those high hazard areas.
Yeah, there are certain parts of the building, like most of the CLT building is going to be low risk throughout most of its life, but those it's not best suited for every. CLT is not suited for every single situation in every building, and so you might look at using alternative materials in those higher risk areas, or mitigating in some other way, like as we discussed, sensors and things like that, or it's, again, design decisions really that try to keep that risk down.
And I suppose more generally, are there any other questions or themes that you've picked up in terms of the questions people have been asking, or any takeaways that you really want to emphasize for everybody here today? Either of you?
I'm just scrolling down this here. There's a lot of interest in moisture sensors. So that seems to be a theme. I think it's an area where it's relatively new, I suppose, and I think the technology has advanced a lot in recent years. So I think it's an area where it is definitely worth making sure that you've got the most up-to-date information on what those systems can do, and also quite often when you present it in a kind of project scenario, there's some kind of typical kind of pushbacks on that. One would be cost. So understanding what the cost is before you propose it on a project is useful. And the other is the kind of perception, perhaps, that the design isn't very good. That's why you need this extra thing. And I think in response to that, I think it's worth noting that this kind of thing would be useful for any building, not just timber buildings. There's leaky pipes or leaky roof, leaky facade is going to be a problem pretty much any material that you build a building out of, and we do have the technology to do it now. So not presenting it as a wholly timber specific thing and a wholly you've got a bad design, therefore you need this extra thing.
And I've got quickly, I can see a couple of questions that come in. Someone's asking, when you measure for moisture, would you expect moisture to be consistently found between L1, L3, and L5? So do you need to measure all the lamella? Not really. The top lamellas, top couple that have got an end grain exposed on the edge or side, you can measure them, or even just measure one. Because if you've got moisture uptake in one, you've probably got moisture uptake in all of them, because the water percolates down through the joint. So I tend to just, and that's, and when it comes to drying these things, you can't be that precise. You just need to, you're going to have to dry the whole joint anyway. So just take it in the top lamella. That's where it's likely to be wettest, or in the second lamella. You don't need to do every single one. Someone said, if you adopt active drying, how do we control the heating temperature to avoid the timber? Well, it's temperature control. You don't want to blast the thing at 50 degrees because you'll cook the wood and it becomes embrittled. And then you're going to get very rapid drying that will stress the glue lines. So it's about active drying is still a controlled process. So you should speak to drying contractors, but 20, 25 degrees is quite a common temperature. I understand. It'd be worth checking. And with that, in combination with dehumidified, desiccated air, that's a very common way of doing it. But just, you do have to be careful not to cook the wood. And someone asked if monitoring probes remain embedded for use phase monitoring. No, the monitoring probes don't, but that's what we're talking about, the digital sensors. Maybe they asked before I got into the bit about the digital sensors, but there's a few questions.
Actually, on that note about sensors, do sensors really need to be designed in from the start in terms of where they're going to go? and where they're going to be? Are there some sort of rules of thumb about where a sensor obviously should go on a CLT project?
There's no regulation, but my view would be it depends on your risk zones, right? So with your design phase, we're going to try to minimize risk zones by pitching roof panels, those sorts of things. So it's interesting that you asked that, because if you've got a flat roof, I've seen there's various products out there, kind of like strips of sensors that are laid grid fashion or a long flat roof over the entire flat roof, and they will work, and they'll give you an early warning system of a leak somewhere along that line. It doesn't really tell you whereabouts precisely, but it's a good starting point. It doesn't narrow the field that much. But if you've got a pitched roof, it doesn't mitigate the problem, which is the flat roof. If you have a pitched roof, now you can put your sensors at the bottom of the pitch, because that's by far the most likely area that you're going to need to do it. I'd also suggest that any gutter outlets. I've seen a few buildings where you've got a leak in a gutter outlet that's gone behind the cladding and run down the facade and decayed out all the panels down the facade of the building over several stories. Now, if you had a moisture sensor there on every gutter outlet, every downpipe, rainwater, any penetration in the roof or something like that, now you've got an early warning system where you're most likely to have a problem. So I say there's no formal guidance or regulation, but that is my view, and that'd be my recommendation.
I think anyone who's worked on historic buildings will also have a kind of an eye into where do things go wrong first. And yeah, it's gutters, behind parapets, valleys, all those sorts of areas where water naturally wants to go to.
Brilliant. Well, we've run out of time now, I think, but thank you very much for two fantastically good presentations. I've kept a note of all the questions, and I'll see that whether we can answer them and get some answers back to all of the various attendees. I'm just going to leave by reminding everybody about our next webinar, which is coming up on Wednesday, the 16th of April, where we'll hear from DRMM and the rest of the project team behind the Workstack building, a very low embodied carbon office and commercial building in southeast London. But so do join us for that one. But yes, I'll just say thank you again to Nick and Matt, and to everybody. Have a great afternoon. Thank you.